Okay, Tarun, maybe there was some issue with the microphone also, so that may be a reason that voice was not audible. You can write it here. Your question, you can ask your questions here. I think you are audible now. Yeah, just go on. Okay, audible now. Okay. Wait. Yeah. Yeah. Yeah, in India, they are just copying the report. Okay, so actually, what they go see what is now environmental laws in India are as strict as European and US laws. Okay, so don't think like European EIA they are doing some better EIA than us. Actually, they are more focused on mitigation and adaptation type of thing, and in India the focus is more on project approval. Okay, so this is kind of a difference which I see in India and the foreign EIA. But the main the planners which have drafted the EIA regulation. So EIA regulation is as strict as the foreign EIA regulation because it is mostly based on the NEPA Act itself. Okay, and EIA itself has come from the NEPA Act, the US Act. Okay, National Environmental Protection Agency Act. Okay, so I think if EIA is followed, let's say I was going through this current news article of tree felling in Hyderabad University, Central University campus, and there we could see a lapse in the whole thing because EIA has classification like category wise. They could see that this is the scope of project, so this will require EIA, this will not require EIA. They don't go into detail and much specific into that. I think the EIA in India should be like ground based. Like if there are forest or something, so whatever be the quantum of the project, be it 10 acres or 100 acres or 4,000 acres, doesn't matter. Even if you have 100 acres of forest, you have to preserve it. Okay, so this is one of the thing which I see in Indian EIA is lagging. Other thing is that key policy makers are not much taking into account the EIA report. They are just looking into that ki, okay, EIA has been done, that's okay. This is the kind of um, this is the kind of response here from the policymakers. So that needs to be changed, I think. Okay, any huh. Hmm. Underdeveloped states are ask money for the developed states from whom? From the developed states in India. I think itself actually the kind of comparison you are drawing is I think not correct exactly because in COP what happens conference of parties the industrial revolution basically happened in US, UK and Western countries. So they were the major emitters of the carbon dioxide and other gases in the environment. And basically, what happens that when these new countries like China, India, they started developing, then they started to frame strict laws for environment. So that is gonna affect the industries which are gonna come here in India and China. So they were like, "Ki, you have polluted the environment, now you are framing the laws and we are getting affected. So there should be common but differentiated responsibility, CDR. So yeah, we need to reduce the emission, but your responsibility to reduce the emission is much more than what is my responsibility in reducing the emission. Okay, so in this mechanism, the developed countries said that ki we can have some trading mechanism, carbon trading, like Kyoto Protocol was there. That was some result of COP 5 or 7 maybe. So they said that ki okay, we are gonna fund the clean energy projects in your country, like clean development mechanism, joint approval of projects, something like that, and we'll give you money to like if you are gonna require some pollution control devices, so we will provide you the technologies also for the pollution control devices, because ultimately if you are in an ocean and the boat is sinking, I am just drawing a comparison, so whether you are a rich or poor doesn't matter, you are gonna go down into the ocean. Okay, so similar here, global warming is increasing whether you are a developed country or developing country, it doesn't matter. So they started to say that ki, okay, we will provide the technology like electrostatic precipitator or maybe some advanced technology, we'll also fund those things so that you guys can actually have a much larger scale of pollution control here in India itself. So that was the main concept there. Now you are drawing a comparison with the developed and underdeveloped states in India. So yeah, if you see on that scale, that yeah, the developed scale, like the industries are more there, so they are like contributing more to the global emission, but the global CO2 emission maybe. But doesn't matter if you see the list of cities, most polluted cities in India. Most of the cities are there in the underdeveloped states like Bihar itself. Like some of the cities of Bihar, UP are top five in the top five of the emission. Okay, so that is also a major thing is that ki if you are saying about the money should go to the underdeveloped state. So if you see the kind of contribution which underdeveloped states made to the economy of India, like tax paying or economy, and the developed states make to the economy of India, they are actually subsidizing the underdeveloped state, which is kind of a necessary also, because India is whole as a country. It doesn't mean that ki you are developed then you will think about yourself only, and then some parts of India will remain underdeveloped. So this is not the case. They are actually paying to the government of India, and government of India a lot of subsidies and many things to the developing states also. Now the matter is ki how they utilize the fund is also important. If they are gonna give the freebies and waste their money, then that is gonna cost them a lot. They need to go for good services industry which are less polluting, manufacturing industries, some of the industries which are high scale like AI, robotics, all these things are coming up. So if they are like they are lagged behind in the industry, like they didn't got the industry, but now industry is going down, much of the focus is on AI, machine learning, all those things. So these doesn't require any industry or any, these just require right kind of policies and right kind of people, which I think these are evenly distributed in the India. So these underdeveloped states like Northeast India, UP, Bihar, much of the Jharkhand also, West Bengal also. So they have good human resource. They can put their effort on this type of thing like AI, ML, and they can become the leader in that. So that can also fetch them money, na? Doesn't mean you have industry or not. You can develop in some other area also and make a global leader. Okay. Any other queries, any other questions or any discussion? Okay, so if there are no queries, then let's start. Actually, I am a bit tired coming directly from the experiment. I'm doing PhD on energy and environment, like waste to energy. I'm working on converting waste to some valuable energy resource and materials, because India is generating a lot of waste these days that needs to be tackled. You cannot dump the waste infinitely. You could see heaps of mountains are getting generated in Delhi, like Bhalsawa landfills, Gazipur landfills. So that needs to be stopped, and some utilization has to be done for that. So on that field, I am working actually. some advanced technology like gasification, pyrolysis, all those things. Okay. Okay, so let's start this NPTEL live session. Good afternoon, everyone. I am Rohit. I am taking this live NPTEL session on the environmental impact assessment. This is live session 11 being conducted on 6th of April 2025. This course is taught by Professor Harshit Sosan Lakras. He is assistant professor in Department of Architecture and Planning, IIT Roorkee. And I am Rohit. I am basically a PMRF scholar in IIT Bombay. So I will be taking this live session. The teaching methodology remains same. Every Sunday, 3 to 5 we are meeting. And if you have any doubt, doesn't mean it originates from lecture or non-lecture doubts. Also, if you are read something, you are free to discuss here. I am totally okay with that. Any environmental or even energy field out, I am totally okay with that. You can always raise your queries in the chat box, or you can raise your hand and ask it in the class also. So let's start this session. So first question is basically which options among the given option is a component of monitoring and evaluation of a resettlement action plan. Okay. So basically resettlement, in the last week also we were talking about this resettlement type of thing. Okay. So resettlement basically when you are going to have some project like government is focusing of building a dam, let's say in a specific region of India. So the people needs to be relocated, but that doesn't mean that they can go anywhere. So government needs to provide a proper rehabilitation plan for them, kind of resettle them from one place to another. They provide them economic opportunities also. They provide them compensation also if their livelihood is affected, their lands are taken away. So all those things are very much important when you are working on these type of things. Okay, resettlement. So let's know more about the resettlement. So monitoring and okay, the answer here is all those things are important like performance monitoring, impact monitoring, completion audit, all of the above. So correct answer is all of the above. Okay, monitoring and evaluation plan components like performance, impact, and completion audit. All those things are important. Scoping land acquisition and resettlement. So most of these things are related the land acquisition here. Okay, scoping land acquisition or resettlement. So establish a multidisciplinary team, review the project design, review the existing primary and secondary socio-economic data, benchmark other projects, develop project maps and zones of project influence. Okay. Let's say we'll see a resettlement guide for people affected by dam development. So one of the thing is like most of the resettlement India happens due to some government projects. Okay, sometimes also due to like industries also, but for industries also basically governments allot the land. And so let's have this. needs to be done actually. These things are quite complex, and when they are actually to be done on the ground itself, that also require a lot of effort from the uh, government machinery, and that requires some setup plans and regulatory actions also. Okay. Match the components of standard resettlement action plan given in group 1 with their description in group 2. So livelihood restoration is basically when you are measures to improve and restore livelihood of displaced people. Schedule is basically covering all the resettlement activities from preparation through the implementation, how resettlement is linked to the implementation of the overall project. R is baseline study, that is summary of studies undertaken including census, surveys, socioeconomic caste studies, key people interview and focus groups. Eligibility and valuation and losses of components is methodology used to value losses under local laws and supplementary measures need to achieve full replacement cost. So this is the component of a standard resettlement action plan. So whenever you are going for a resettlement, so there needs to be prepared an action plan itself. So that will include all those things: project description, impacts, legal framework, baseline studies, stakeholder engagement, eligibility and valuation of losses, livelihood restoration, housing, organization responsibilities, schedule, budget, monitoring, evaluation, and reporting. Okay, match the project influence zones in the context of EIA in group 1 with their description. So primary zone is basically zone of direct impact area. So primary is basically some zone where there is a direct impact, where the project activity and facilities are actually located, including like access routes can be one of the thing, water, power supply network, supply chain, and employee accommodation. Secondary zone is larger region in which the project is located and will encounter the main economic impacts from the project, including the influx of economic migrants as well as employment and business opportunities. So this is from the slides itself. So you need to focus more on these type of slides when there can be question in the exam also. The extent of resettlement impact depend on the following: magnitude of the displacement, characteristics of the project and its mitigation measures, characteristic of the community, all of the above. The correct answer is all of the above. Okay. Extent of resettlement impact depends on magnitude of the displacement character. So this is what the question was about. Okay. State true or false. Indigenous people are one of the associated environmental and social standards as per AI. So this is a true statement. Okay. Match the following terms of group A with their description in group B. So this is kind of a need to understand type of question. So I leave you guys to actually tell me the answer and see if there is any thing which you don't understand here. Okay. Okay, so let's see if there are any questions. No. Okay. So resource efficiency is basically like measure of the inputs and waste generated in the proper development at every phase. Okay. Closed loop system are where waste products can be used as a resource either in the same process or elsewhere. So that is called closed loop system. Energy balance is sum of energy going into this system must equal to the sum of energy going out plus any changes in the composition of that system. Mass balance is sum of mass going into this system must equal the sum of mass going out of the system being stored in the system. Okay. So these are actually taken from here. Measure of the inputs required in the proper development, measure of the waste generated, okay, energy, water, etc. Energy and mass balance, closed loop systems. So these are kind of closed loop system. Okay, you can see here like if there is a production, then packaging and distribution, use and maintenance, recovery, and the material sources, and there are actually output input also. But whatever the waste is generated, that is gone into recovery like recycle or reuse. Okay, use and maintenance, minimize waste. Okay, so now there will be like what is the difference between recycle and reuse. So in reuse, like let's say I have a big polythene bag. So I just bought some cloth from the market, and they gave me the cloth in the polythene bag. Now, next time I went to the market, but I am using the same polythene bag. That is reuse. Recycle is something like I collected that polythene bag and then recycled it and cut into the raw material and then made again input into the factory that produce a new polythene bag from the old polythene bag itself. So that is kind of called recycle. So that actually minimizes waste also. You can see here mass balance example, one of the example of mass balance here. The mass balance was, so it's kind of a pyrolysis process. So biomass is here, water in the water coil condenser 8 liter per minute, and then nitrogen 4 liters per minute, and water in water out is mass balanced out. Biomass, whatever biomass goes, so that comes out as char, bio oil and gases. Okay, and nitrogen whatever goes in goes out. Okay, so this you can see it here itself. Okay. So if you will see, you will observe that the sum of these three are actually equal to the sum of the biomass itself. So this is kind of an example for mass balance, and this is example for energy balance type of thing. So whatever input energy there, energy conversion system. Let's say this is a power plant, an electrical power plant. So energy input can be in the form of coal. So whatever energy is in the coal, so energy will be converted to electrical output, and then some energy will be lost through irreversibility, like degraded energy, kind of energy lost to the atmosphere. Okay, so this is kind of energy balance. So I will suggest you guys to have a look at these two things, mass balance and energy balance, and if there are any questions, please feel free to ask. Okay. Okay, so let's see some videos on this resource efficiency. As per the life cycle assessment, resultant waste from the process is considered under which impact category? So basically, it's a downstream. Okay, so downstream like after the process has occurred. Upstream is before the process has occurred. Okay, so upstream is like where and how original material is produced, processed, and downstream how resulting waste are managed. So these are upstream. Okay, this is like a product manufacturing process, material processing. So whatever waste is upstream, this is downstream. Okay, so reuse, recycle, all these things are typical product life cycle. So let's say let's look into what is a kind of a life cycle assessment. So you will get a good understanding about this life cycle assessment. So you could understand the life cycle assessment thing, like how the life cycle assessment actually takes place, what are the different steps there, how they are actually done. So all those things are very much important when you are going to do a life cycle assessment. Okay. As per the life cycle assessment handbook, a guide for environmentally sustainable products, choose the correct option for the blue box to complete the general methodology. So goal, scope definition, inventory analysis, interpretation. So this is basically impact assessment. Okay. The correct answer is answer A. So this you can see it here also. Mary and Curran Environmental Life Cycle Assessment Handbook. Match the following terms of Group A with their description in Group B. So risk. So these definitions are very much important when you are talking about the kind of words. What is the meaning? So risk is basically outcome of hazard or hazardous event. Okay, hazard is something like inherent property of an object to create damage to humans and environment. Okay, chronic hazards are like a hazard that cause harm over a period of time through long-term exposure, typically uh, include toxic chemicals and low-level radioactive material. Hazardous event is basically an event where humans or other species are exposed to a hazard at high levels and harm to humans or environment occurs very quickly. So these are the definitions which are listed here, which you can also look into, like hazardous event. Okay, example, natural gas is transported and distributed, such as case of Bhopal Union Carbide accident. Risk is then basically outcome of hazard or hazardous event. So a hazard is inherent property of an object to create damage to humans or environment. Objects can be inherently dangerous or exposure to them can cause injury, hazardous problems, or loss of environment. So as let's say there is this two, like hazard, and so see this hazard is something that has a potential to harm you, like shark. Okay, shark in the ocean, and you are going to swim in the ocean. And risk is the likelihood of an hazard causing harm. Okay, so hazard is something which can harm you, and risk is the likelihood of that causing harm. Okay, okay. So this is hazard, risk, vulnerability, exposure. This is kind of a very important. So before that, I want you to look into this, like understand this, what does means. Okay. the difference between hazard and risk, and the video was very much explaining the things very beautifully about what constitute a hazard, what constitute a risk, and how risk can be lowered. Actually, they have given an example of shark also, like placing a barrier in the ocean that will actually lower the risk. The process of evaluating and assigning a numerical value to the risk associated with an industry, which also includes practices of probabilistic safety assessment and probabilistic risk analysis, is called. So that is called a quantitative risk assessment because we are calculating the values. So we are calculating assigning a values to that. That is basically a quantitative risk assessment. So this is kind of a qualitative, like you give a qualitative value, likely, possible, unlikely, remote, minor, moderate, all those things. You don't give a perfect value to it. So this is kind of a QRA, quantitative risk assessment process. So first thing is identification of QRA scenarios, like risk scenarios, and parts count, physical effects modeling, event tree analysis. So these are kind of a frequent assessment, consequence assessment are there. Then combining these, we have risk analysis. Then there are outputs like LSIR, IRP, APLL, fine curves, FN curves. Okay, so all these four are actually risk evaluation. And then we perform sensitivity analysis, cost benefit analysis based on these. Okay, these are quite important. So you should actually look into this. Okay, so you can read this PDF also. That will give you a good example of this report. Actually, you can read this report here. The region between lower tolerable limit and the upper tolerable limit, risk in between the two values, is known as. So that is basically a LARP region. Okay. So this region is basically a LARP region. This is from here. Okay. Broadly accepted region, unacceptable region. Risk cannot be justified except in extraordinary scenario. This is tolerable if allowed region. Okay. Risk is taken only if a benefit is required. So tolerable only if risk reduction is impractical or it cost is grossly disproportionate to the improvement gain. Tolerable if cost of reduction would exceed the improvement. So I will give you an example. Let's say you are in the ocean and there is a hazard in form of shark. So shark can attack humans. Okay. So one of the thing to lower the risk is like you install a barrier to like to that. So barrier will cost a lot of money and sharks are not so much. So to put that much money where sharks are not so much, so that is basically a tolerable risk is there. So risk can be tolerated. You cannot the uh, that is basically you are not going to reduce the risk because the cost is grossly disproportionate to the improvement which is gained basically. So risk can be balanced. Okay, so this is kind of a balance risk cost. Okay, so this is very important. So I will leave you 1 or 2 minutes on this slide actually. Okay. Identify the most comprehensive framework for life cycle assessment among the following: cradle to grade, cradle to site, cradle to use, cradle to grave. Okay, so correct answer is cradle to grave. So this is general life cycle flow diagram. So raw material acquisition, that is cradle, material manufacture, product use, and then final deposition, landfill, combustion, reuse, recycle. So all these things. So this is a typical general diagram. Okay. Assessment of the resource performance of buildings. So this is also kind of a building life cycle assessment. So you can see it here, raw material supply, all those things. So this is up to cradle to gate. So your construction process starts here. Cradle to site, cradle to use. Like everything has been constructed, now you are using it. Cradle to grave, post project. Okay. So this is a typical LCA diagram. So you can see the different types of emissions and how they are actually impacting. So let's look into this basically and understand the different emissions. So this you actually saw about this life cycle assessment, how the upcycling and downcycling, all those things are actually happens. Okay. Manas is saying, would you please share this presentation? Actually, all these presentation are actually shared with you guys. Don't you know? The whole recording and the presentation itself. Let's say you go here, Swayam. I think I have shown also. You basically go here to the problem solving session. Okay. Click here for the problem solving session. So this is the folder where all the previous presentations are actually there. Okay, this you can get it from here. So all the presentation for all the weeks are here, and these are the videos. Okay, these are the videos for different weeks. Okay. Yeah, in Swayam portal. I hope now you will be able to access them. If there is any problem, just write it in the discussion forum. Okay, so we'll be able to solve it for you. Which among the following option is represented in a water balance diagram? Okay, so water balance diagram is basically water used for cooling tower, not solid waste, plastics. All these things are not basically related to water. So this is a typical water balance diagram for a paper and pulp mill. So what water is entering, where the water is going, how much is getting out, treated, and then left to the some source out. The risk management framework is a component of EIA. This is true. So assessment and risk management framework. So what are basically these two? So I think we can see this video after one or two questions here. So actually here. What is the following example of a chronic hazard? So prolonged expiry to radioactive material, risk of falling objects, risk of so this is a chronic hazard. There were two types of hazard, chronic and then one another type, temporary type of hazard. So that is basically related to temporary things. Long-term exposure and then short-term chronic and natural hazard. Okay. Match the following terms with group A description in group B. So cumulative impacts, basically cumulative impacts are basically impact that arise from the successive like incremental type of thing. Valued component is basically environmental feature that may be affected by a project that have been identified to be concerned. Indirect impacts are something which has some indirect relationship, like impacts on the environment, which are not a direct result of the product, but often produced away a result of complex pathway. Impact interaction, the reaction between impacts between different impacts of just one project or between impacts of other projects in the areas. So this is kind of impacts. Okay, impact A, impact B. So this is okay cumulative impacts, like two impacts get added up. Then impact interactions are also there. Then valued ecosystem component. Okay. Bhopal Union Carbide accident is an example of what kind of hazard. So it's a basically a acute hazard. Okay. So Bhopal, this is kind of a document by Elton Gomes. So you can read it here. It was a very, what you say, a kind of a unfortunate event that happened, and due to the mismanagement by the company Union Carbide itself. So yeah, hazardous event where humans and other species are exposed to hazard at high levels and harm to humans or environment occurs very quickly, like natural gas and Union Carbide. So this was a very good, what do you say, video which I found about Bhopal gas tragedy. I think you guys should see this. a very, what you say, a kind of a unfortunate event that happened in 1984, and this type of thing can be avoided also, like kind of with proper checks and safety and balances. So this, that is why EIA is very much required, environmental impact assessment. Like if there is any leaks or something, so it can happen. So yeah, in 1984, the environmental laws were actually coming up in India in 1986. Because of this tragedy itself, there was so much uproar in the people that government has to frame a legislation called Environmental Act. Okay, so again it's 5:07, so I think I need to stop here. So I will upload the slides on the portal, and you guys can actually go through the slides, and if there are any questions, please feel free to ask me. Okay, so thank you for attending this live session, and we'll meet again uh, for the last session on the next week, Sunday. Okay. Okay. So there are some, like some additional contents here which you can see, and I suggest you guys to actually see these content. These are very important, and this will help you guys to understand more about the environmental impact assessment.